What is up, everybody? Thank you so much for tuning in to episode 2 of Physics with Elliott. You all smashed the like button on our last video, so I thought I had to bring another one to you. This one's brought to us by Kyle the Eagles fan 34 over on Twitter, and it's about James and his skateboard. So James wants to try out this new skateboard park and this new super thrilling skateboard ramp. But if we notice here, there's a sign that says that you must be going at least 12 meters per second if you want to get over this ramp and cross over to the other side. So if James is on a ramp that's 10 meters high, and the edge of the ramp is at 6 meters high, how fast does James need to start off going in order to jump off the ramp at least 12 meters per second? And this problem deals with conservation of energy, which states that all the sum of our energy in the beginning is equal to the sum of our final energy. And in this problem, the two types of energy that we're dealing with is our gravitational potential energy and kinetic energy. So if we split up the sum of our energy into the gravitational potential energy in the beginning, which deals with how high James is off the ground, plus the kinetic energy of James in the beginning, which is how fast he might be moving, is equal to the gravitational potential energy of James at the end, plus the kinetic energy of James at the end. And if we want to expand these even further, we can go ahead and say that mass times gravity times his initial height plus 1/2 times mass times velocity initial squared is equal to mass times gravity times his final height plus 1/2 velocity final squared. And we notice here that there's a mass value in every single one of our terms. So if we go ahead and divide by mass, we're going to get rid of all of our mass terms, which means, oops, I forgot a mass in here, which means that mass is actually irrelevant to this problem. So we're left with, and we can go ahead and start filling in values. We have 10 meters per second squared times 10 meters, which is his initial height, plus 1/2, and our initial velocity is what we're trying to solve for, is equal to 10 meters per second squared times 6 meters plus 1/2 times 12 meters per second squared. And we go ahead and simplify this down into 100 joules plus 1/2 initial velocity squared is equal to 60 joules plus 72 joules. And if we combine these and move it over, we're left with our initial velocity squared equaling 16 meters, or 16 joules. And so our final velocity, or our initial velocity, what we're left with, is 4 meters per second, which means that James has to be going at least 4 meters per second when he starts going down the ramp, so that when he's at the bottom of the ramp, he's going at least 12 meters per second. So thanks so much for staying with us on this video about the conservation of energy. Please make sure to like, comment, and subscribe to this video. There's going to be a physics question of the day underneath in the description. So thanks so much, and I'll catch you on the flip side. Adios.